you guys want to later, go ahead and download that and read through it or whatnot and brush up your memory.
Okay.
All right, let me get started then.
Yeah, go ahead.
Since everybody here is pretty well familiar, I guess, with Synergetics, we can do different things along the way. I'm going to share my screen now. Is that the picture of the icosahedron pushed down? Dawn, I'll ask you so that I can tell whether, can you guys see my screen there?
Yes, we can. Yeah. We see
okay,
your
wonderful. Yeah, you see my foot. I know I'm funnier than can be. So anyways, so there's the Tensegrity icosahedron. I took a bunch of pictures of it transforming. I talk a little bit about how this models the behaviors of the quarks and the bosons in one of my papers in understanding gravity and the strong nuclear force. All the papers I'm talking about now will be or are on the website of FSI. Just like click on my name and see where my posts are, and it'll come up with one of my post links. Let's jump right in then. My presentation, From EMR to Me and You, a presentation on the unified field. How does electromagnetic radiation form structure? I'll go through this, and folks, if they want, who are just going to be looking at it on the internet, if it is recorded, can read the words themselves. I wasn't trained by academia, so I didn't know that I was supposed to have a lot of beliefs about nuclear structure. If I would have been trained by academia, I would have never discovered the following information. This information goes beyond belief and blind faith. Ventures from the realms of belief and faith into the realms of understanding and certainty. Discovery does not preclude further discovery. Here's just a little bit of background information. The nuclear equations, like the formulas for the polyhedrons, are all based on the total number of spheres, vectors, volumes, or angles within the omnitopological aspects of the various polyhedrons at various different sizes or frequencies. Those of you who are familiar with my work may recall some of these equations, such as 137 to the second power minus 1 divided by 2 equals 9,384. I developed this equation before I read in a book by Frank Close called Particle Physics that it is still unknown today why the proton's megaelectron voltage is exactly 938.4. You can imagine my excitement when I was made aware of this fact of physics. I drew up my charts for the polyhedrons because I was trying to find whole unit number ratios between the electron as a mass of 1 and the proton as a mass of 1836 and the neutron as either a 1838 or 1839. When I drew up my charts, I was following Fuller's thinking, and I didn't know much about nuclear physics except what Synergetics was teaching me. The realization that 938.4 MeV of the proton was related to the number 137, which is the inverse of the fine structure constant, was exciting because when I drew up my charts, I planned on studying the first 128 tetrahedral frequencies. But then I read what Feynman said about the number 137. He said, every nuclear physicist should have this number 137 pinned on their wall, and that they should wonder about it all day long. This number, the fine structure constant, one of the biggest damn mysteries in physics. With this in mind, I extended my charts to the 144th frequency. As I explained in my paper, Polyhedral Transformation Phasing and the Number Patterns Associated with Nuclear Structure, the numbers which transition phase at the 137 frequency tetrahedron show us clear indications of a relationship between nuclear structure, quantum mechanics, and the isotropic vector matrix. The 136 frequency tetrahedron has 2,571,216 total number of vectors. Synergetics says that vectors represent forces. It says that these vectors never show up singly. They only show up as the full family of forces, operative, within any given event scenario. I found that I could mathematically destructure the total number of vectors as forces into 137 times 938 times 2. You see, my mind was working like a hadron collider because it was taking all these vectors and blowing them up and examining the forces and masses which were derived from the one event scenario. This showed me that the total number of vectors in the 136 frequency tetrahedron was ratioing the force measure of the fine structure constant with the MeV of the proton. It was only later that I discovered that the inverse of the fine structure constant was actually 137.0359 and the MeV of the proton 938.27. I had a lot of other number patterns, so I didn't stop my research. Recently, I came to understand that it doesn't matter what the exact numbers are from physics because the isotropic vector matrix is the actual universe design, science, engineering coordinate system. which universe uses to structure all of her polyhedral creations. With this in mind, let's begin our explorations. The IVM in Tensegrity, a 5-year-old boy discovers nature's coordinate system, the isotropic vector matrix. Or was he 4? Fuller says in Synergetics, Avogadro discovered that under identical conditions of pressure and heat, all elements in their gaseous state always consist of the same number of molecules per given volume. I said, can I make a vector model of this generalization of Avogadro's? I found that I had already done so in that kindergarten event in 1899. This was when I first made the octet truss out of toothpicks and semi-dried peas, which interstructuring pattern scientists decades later called the isotropic vector matrix, meaning that the vectorial lengths and interanglings are everywhere the same. More on the IVM to follow. In Synergetics, figure 76502, Fuller demonstrates the Tensegrity sphere as the only real sphere as an operationally transformative field complex of energy as struts and gravity as the omni-embracing external Tensegrity net. He characterized this as a physically modelable representation of a unified field of structure, uniting one gravitationally tensive force field to create a stable structure by uniting separate energy compacted compression struts, one wave field of gravity connecting and structuring multiples of particles of energy into one comprehensible polyhedral field of structure. The Tensegrity model shown below is made from one piece of string, which is looped around the 12 vertices of the system and tied with one knot at the end of its circuiting. Just as no two struts within the Tensegrity structure ever touch one another, neither do the spheres which they create. The spheres are intercohered tensionally by the interconnecting energy lines of action. These may be seen as loops, lines, vectors, electromagnetic gravity, interconnections, or boson flux tubes. These gravity boson flux tubes then interconnect and intercohere the charged strut vertexial quark ends of the Tensegrity field structure. This then appears as matter to conscious time-oriented creatures made of the same scaled frequencies as the atomic and molecular Tensegrity structures. Don, would you do me a favor and tell me when 10 minutes is gone? I know I got a little clock here, but I just want to make sure I'm kind of going through okay. And maybe tell me when a half hour is gone.
All right.
No worries. Yeah, tell me when a half hour is gone, because I'm just going to keep going. It's yada, yada, if that's okay. I got some more pictures and stuff along the way.
I'll time you.
So Bucky says, for every point in the universe, there are 6 uniquely and exclusively operating vectors. A Tensegrity icosahedron is a point. A Tensegrity icosahedron has 6 vectors and is a point-twoable field complex. The point struts point in 2 degrees of oppositely oriented freedom, and they separate the one inside-ness of universe from the one outside-ness of universe. As I said before, so I talk about this in that paper. If you guys are interested, you can read some of that last chapter in Understanding Gravity and the Strong Nuclear Force. Let's move on and talk about some stuff. In The Shape of Inner Space by Xing-Tung Yao, on page 287, figure 12.3, he says that minute rotations induced by gravitational attraction, are measured at short distances and with great precision by the Mark 6 pendulum designed and operated by the Wash Research Group at the University of Washington. If gravity were observed to behave differently at close ranges and to deviate from the inverse square law well established in classical physics, it could signal the presence of the extra dimensions predicted by string theory. These experiments at the University of Washington will prove the falsifiable claim I make that there are no extra dimensions and that the gravitational force never deviates from the inverse square law. My lecture, Planck's constant sets of gravitational constant, explains clearly how and why gravity is created and how and why it ratios to the forces and masses of the subatomic particles the way that it does. Mr. Bedell made me aware that the James Webb Telescope showed us pictures of fully formed galaxies outside of our known universe and beyond the cosmic microwave background radiation, therefore, before the Big Bang. Don doesn't believe in that Big Bang thing. I don't really either. It's interesting to see that he is correct and that it is basically by mind connecting to universal energy field that some of these thoughts probably come through. I wrote about how, so our universe, like all new universe, is created by the externally embracing energy universes lying closest outside of ours, shift phasing away. It's in this way that our universe was sucked into the evacuated space now that we can see beyond the cosmic microwave background radiation, we're starting to see other things. So our locally observed universe is only observable within a specific limiting range known as the cosmic microwave background radiation. I say here that there's these other universes outside of it. And I think that's interesting. Oh, I also say that this may be proven by us. If we examine light from the farthest galaxies in all different directions, we will find that the fine structure constant will vary its strength from one magnetic pole of the universe to the other, but in no other direction will it vary. It will grow slightly less towards one pole, and it will grow slightly stronger towards the other.
About 10 minutes have passed. I'm wondering if you can pause for a second. I just want to check.
I'm happy to. I'm happy to.
We are. We got it.
All right. I understand this is very complicated information, gentlemen. I understand it's on a book that almost nobody reads or studies or understands. There's no worries about it. I'm happy to take as much time as you guys need in the continuing weeks or whatnot to chat a little bit at your guys' leisure. This is not new to me, so I'm happy to share. This is new to me. Thank you, Dr. Gray. In Synergetics, Fuller relates some very interesting yet difficult to understand information regarding what he calls the twinkle angle. The twinkle angle relates to the 5 degrees and 60 minutes of arc magnitude variation between the acute angle of the A quantum module, which is 84 degrees and 44 minutes, and the 90-degree central angle of the LCD triangle of the icosahedron. I have pictures down below if you guys are interested. This 5 degrees 60 minutes is the amount of subtracted from a 60-degree angle to obtain the 54-degree 44 minutes arc related to the neutral attractive repulsive zone of magnets and half-spin particles. The 5 degrees 16 minutes is also the amount added to a 30-degree angle to obtain the 35 degrees 16 minutes of arc related to the neutral attractive repulsive zones of Amperian currents. These angles are related to the fine structure constant and Planck's constant in the following way. Give me a second, you guys. I gotta take a breath. Hey, Lionel, I'm not saying nothing. I just didn't expect to get interrupted. I know this is all boring as can be if you're not into it. And I know I go real fast too, so let me take a quick couple seconds here. Let me drop this down a little bit. You guys can read through that at pinch. I'll read through it in a second here. So, gentlemen, there are 720 degrees of angular variation about the 4 vertices of the tetrahedron. This is the same amount of angular momentum associated with all half-spin particles. A spin of half-spin means that the particle must be rotated by two full turns, before it is the same configuration as when it started. An article, the spin of all electrons is plus or minus 1/2. What this means is that if you're an electron, the world will not look the same if you spun around once. We are spin 1. We have to turn around 360 degrees to get to the same point of view. Electrons have to turn 720 degrees, as if on some terrible acid trip, says Enrico Fermi. All particles that have this strange property of spin 1/2 are known as fermions, such as protons, electrons, quarks. If we take the 720 degrees of the spin angular momentum of a vector from a half-spin particle and ratio it to the fine structure constant and to Planck's constant, we derive the same twinkle angles and magic angles as those in synergetics, electromagnetics, and quantum mechanics. There's a basic difference between 5 degrees 16 minutes and approximately 5 degrees 15 minutes. It is obviously the same twinkle angle with residual calculation error of trigonometric irrational inexactitude. That's from Synergetics. So this 5 degree 15 minutes is related to the 120 least common denominator icosahedron. The 1 minute of arc variance may be important, as we shall see. Planck's constant equals 6.65 times 10 to the negative 34 joules. When multiplied by the electromagnetic force compared to gravity, 10 to the 34 power, h equals 6.65, which is a natural number, 53 divided by 8. The fine structure constant is A is 1 divided by 137. When you take 6.65 minus 1 times 2 to the 7th, and then you multiply it by 1/137th, it equals 5.255, and that is equal to 5 degrees 15.32 minutes. 720 divided by 137. Planck's constant, the fine structure constant, also raised to the 700 degrees of spinner and the tetrahedron, and the magic angle of 54 degrees 44 minutes. Planck minus 1 times 2 to the 7 divided by h, which is 720. Remember, if you read my other work, Planck's constant ratios the great circle geodesic angular momentum. It equals 108.679. So h minus 1 times 2 to the 7th divided by h. Now, when you take that number 108.67 and you multiply it by 1137, the fine structure constant, you get this number, 0.79327. When you add them together, you get 109.472. And that is twice the 54 degrees 44 minutes angle. This angle here, 109.47 degrees, is a central angle which extends from the center of gravity of the tetrahedron to its 4 vertexes, as well as to the center of area of its 4 triangular faces. When we connect all 8 axial vectors from the center of gravity of the tetrahedron to these 8 separate aspects of the tetrahedron, the central angles are all 54.73 degrees. These 8 axial connections create 4 axes. These 4 axes are related to the 4 great circles spun about the tetrahedron. These 4 axes are added to the 6 axes called the isotropic vector matrix, and the 3 axes that man calls XYZ, and the 12 others to form the 25 axes of symmetrical rotations and great circles about the vector equilibrium. These 4 axes aberrate at 5 degrees 16 minutes of angular variation from the 60 degrees of the 6 isotropic vector matrices. Okay, the 4 axes are 5 degrees 16 off of the 6 axes. The central angles of the icosahedron aberrate at 5 degrees 15 minutes. The spinor fine structure constant and Planck's constant also aberrate at 5 degrees 15 minutes. Synergetics says 60 degrees is the vector equilibrium neutral angle relative to which life in time aberrates. Is this eerily prescient that Fuller calls the IVM 6-axis metric of 60 degrees the neutral angle, when the real neutral angle of spin angular momentum of 54 degrees 44 minutes discovered by quantum mechanics is actually 5 degrees 16 minutes off of the IVM's neutral angle? The universe seems to be using the 4 axes along with Planck's constant and the fine structure constant to transition the EMR from the 6 isotropic 60-degree axes of the IVM, which structures the subatomic and atomic symmetries, into the non-isotropic 6-axis metric of the rotating icosahedral field, which creates all the very slightly differentiated, slightly asymmetrical, life-aberrated pulsations and quantum oscillations. This 1 minute of difference between 5 degrees 16 minutes of the IVM field and 5 degrees 15 minutes of the icosahedral field, and the Planck fine structure spinor ratio, seems to be the minute amount of angular variation needed, since no 2 energy vectors can go through the same point at the same time. The angles must vary slightly. This 1 minute difference may be the amount needed to transition phase the energy from the 25 stable axes of the IVM onto the 31 one-way and another way rotational axes of the icosahedral spin field, and then back and forth again. He talks a little bit more about the freezing of the angle and what the 516 means. There's 6 degrees of spherical excess on that 120 LCD triangles face. And then the 516 is the aberration at the central angles. I can explain more another time if you guys are interested in that. I know it gets very complicated. Let's get back to some maybe basics. Lissauge's figures. Just a second. The pictures below show how the 4 individual great circles of the vector equilibrium are bow tie reintegrated into a sphere. It illustrates how 2 or more angles converging at the vertex of a system must leave a little arc gap, which must be jump phase transitioned. The angle from the center of gravity to the vertex of the system is slightly different from the angle of the adjoining Lissauge's figure. The angles never actually start or end at the center of gravity. There will always be a little space in the hollow center of any octave wave pattern generated great circle geodesic electromagnetic polyhedral system. Notice the little gaps here. I'll explain a little bit more about Lissauge's figures in a moment. And just so we can see, then Lissauge's is a figure 8. So the energy then, what Bucky's going to be talking about in a second here, is running like this, like a Lissauge's figure 8. Whoosh. It comes by here. And then at any of these vertexes, it can, if it has enough energy, poof, jump the gap, so to speak. On page 232 of Cosmography, Fuller states, since more than one event cannot occupy the same point at the same time, and since more than one event cannot passage any one point in the universe at the same time, the two great circles cannot cross each other at the same radius or angle, my point, from the system center. We may now see that the electromagnetic waves are not continuous, except in their continuum of local Lissajous figures, and that wave-like particles are finite packages. The fact that all great circles inherently fold into the simple and complex bow ties, which are reintegratable to create spheres, made it evident that the individual 360-degree basic wave cycle that each manifests provides a means of holding information in a local self-regenerative shunting pattern, with releasability into cosmic travel through the tangency points inherent in closest packed together unit radius spheres. What we must conclude is that in view of the fact that two lines cannot go through the same point at the same time, all of the foldable great circles, which can be vertex fastened together to seemingly reconstitute the great circles, represent the actual and only possible pathways of energy. Lissajous figures, Bowditch curves, were discovered as useful tools for science during the early days of World War II. These figure 8 patterns were found to be the patterns that energy was producing in the microworld. These represent the fundamental self-interference patterns of nature trying to achieve the most economical travel routes. Energy continually completes these cycles, and is in this way that nature can have local holding patterns of energy, which can, however, be gap jumped into wave continuums. It's perfectly clear that the point or vertex of contact of the folded great circle with its counterpart, there is a true gap, which explains this phenomena not explained by scientists of what seems to be particle and waves. Waves seem to be continuous and particles seem to be discontinuous. Now we see that the wave is also the particle. It is the Lissajous figure, which with the right gap closing would constitute a circuit. Tuning, I am sure, is exactly this closing of a gap. A solenoid, for example, is used to tune the right number of coils to allow a gap to be closed. Higher and higher tensions are built up until one is able to arc the gap. Okay? This is what I'm explaining in Planck's constant sets gravitational constant when I say Planck's constant is a gap jump measure ratio between all great circle geodesic octave wave patterns of electromagnetic energy. These spherics interconnect between larger and larger omniconcentric internally phasing polyhedral spherics. Understanding that the two Lissajous figures creating one vertex is analogous to how the two intertransformatively phasing polyhedral spherics in an omniconcentric array can have two vertices in critical proximity with each other. This is where the spark gap jump occurs when the electron transition phases itself into the next discrete energy state. This could be visualized as a geodesic dome around another geodesic dome, a little smaller. The transition phase will occur between the vertexes of the system. In the real microworld of quantum mechanics, the gap is the fine structure constant, 1/137th, and the gap jump measure ratio is Planck's constant, 6.625. This is the amount of work-force energy needed to transition phase the electron over the gap and into its next discrete state of the surrounding spheric. This helps to explain what Smolin's talking about in picture on page 116 in his book, 3 Roads to Quantum Gravity. The books I'm mentioning today are all downloadable. I put them on the FSI website. The picture simply shows a graph with lines drawn in horizontal and vertical rows which form squares. This is the lattice which he's talking about. Smolin explains, quarks and strings as conceived by Wilson, space is imagined as a lattice made of nodes connected by edges. The quarks can live only on the nodes of the lattice or the vertexes of the lattice. See, the strings or quantized tubes of flux of the field connect the quarks, but can exist only on the edges of the lattice. The distance between the nodes is assumed to be finite, but much smaller than the size of the proton. For simplicity, the lattice shown here is drawn in 2 dimensions only. And once again, I show a 3-dimensional display of this consideration regarding quark and boson behaviors and the Tensegrity icosahedron in 2 papers, Understanding Gravity and Strong Nuclear Force and Transformational Tensegrity Field Complex. For anybody who's interested in my work, those are available at FSI. Now we're getting into it. Structuring MR phase 1, so half hour's gone. Discovery does not preclude further discovery. My 2 newest equations are because Bob Gray gave me some new information. I was going to go over this a little bit, I'm only going to go over it for a few seconds. Bob Gray found out that there's certain angles. See this angle right here, everybody? That's called alpha. That's 6 degrees here, 35.25. Up here, that's the amount from here to here. Oof, if you would go all the way, you double that, it's 70. He found out that the force of one ampere current element due to another current, excuse me, I'll slow down. One ampere current element's force upon another has certain attraction and repulsion ratios based on Ampere's force equation. The radial force is given by that equation. The radial force is neutralized when the Amperian currents that are a certain angle to one another, and that angle is 35 degrees and 16 minutes. 0.264 degrees is the same as the 16 minutes. And here's the wonderful calculations that Bob went through to understand that. 35,264 is 3516. The angle is 5 degrees, 16 minutes more than the 30 degrees. That's the twinkle angle of Synergetics geometry. Bob then explained there was another interesting number here. This angle here, and this cone here, which is drawn. It's easier for me to see this proper cone display when we put the figure on its square plane instead of on its triangular plane. And we draw the cone out from the center of the cone to the center of the face points. The mid face points of the 4 triangles creates that same angle. But nonetheless, the angle in alpha is expressed at 54.73561. These are ratios within the vector equilibrium. Hang on just a second. When we restrict the dipoles, and you can use 2 little magnets to play this with yourself, 2 bar magnets, you can feel this zone of attraction starting and stopping. The magnets then right here, I want to go back for a second because I want you guys to notice something here. Okay. Maybe I did not have that one. So, when these 2 Amperian currents are in this position, they're attracting each other. When they're up here, they're repulsing each other. And then right about here, they're in that neutral zone. I'm saying that because right now you'll notice that the magnets are the opposite. I'm sorry. When the magnets, hold 2 bar magnets together and try and push them together with both the positive pointing up that way and the negative pointing this way, and they'll repulse each other. And when you're moving this magnet around with your hands, you'll notice that right about at this angle, whoa, it's neutral. And then it starts to then attract each other. Boom, right here. There's the force equations that he uses to identify the angle that this neutral zone of attraction and repulsion within magnetic fields as well as within quantum mechanics, I'll show that in a second here, is this angle here, 54 degrees, 44 minutes. He talks about, and I'll explain the space quantization in a moment. In quantum mechanics, the spin angular momentum vector with respect to the axis of the applied magnetic field is quantization, and that angle is this 54 degrees. When technology discovered that, they utilized that angle when they made solid-state nuclear magnetic resonance spectroscopic imaging available, and that created what they said was the magic angle of spinning. And that's when they applied a magnetic field to any of these half-spin particles, it shift phased itself for some reason, and it moved to this angle here, regardless of whatever angle it had before. So this is an interesting thing, that magnetic moment properties of the quantum mechanic particles are aligned with the magnetics that are in the material world. And remember that the Amperian currents run opposite as attractive and repulsive forces when they're running parallel to each other. So this angle is 5 degrees, 60 minutes less than the 60 degrees. That's the twinkle angle in Synergetics. So it's at this 54 degree, 44 minute angle that the half spin particle stabilizes vibrating precessional angular momentum. And so the resolution to the picture is better. This is the coupling angle. It uses to couple itself to other EMR and other half spin particles. In quantum mechanics, they define, the definite magnitude and direction of one component of angular momentum is known as space quantization. Michael Fowler in this article, available there, says, is there any way we can actually see some effect of this directional quantization? The answer is yes. Because the electron moving around its orbit is a tiny loop of electric current and therefore an electromagnet, imagine, whoops, basically then the loop. Oof, there's a loop going around there, right? So the electron's moving around its orbit, it's a tiny loop of electrocurrent and therefore an electromagnet. So if we switch on a magnetic field in the direction of the z-axis, the energy of the atom will depend on the degree of alignment of its magnetic moment with the external applied magnetic field. The magnetic field from a small current loop is like that from a small bar magnet aligned along the axis of the loop. Well, maybe next week I'll demonstrate a little bit with magnets and talk a little bit more. Let's see. Yeah, we'll pass this. I don't have time. So now phase 2, structuring MR. We're trying to understand how all this builds up to structure. We think we learned how to quantize space by understanding that we can induce changes to the angle of the particle spin by applying a magnetic field. And we think of this exact angular quantity as a quantization of space. I didn't learn any of the terminology from nuclear physics and quantum mechanics until after I studied synergetics and developed my theories and unknowingly adopted many of the terms from these fields. My word associations were always to polyhedrons and their behavior characteristics. So when I began to study these different scientific fields, I was amazed at how they use similar terms to describe similar behaviors, but in a rudimentary and half-guessing fashion. Synergetics seemed to explain to me clearly what the sciences are only still hinting and grasping for. Synergetics adds to Euler's topology its discovery of the mathematically generalizable constant relative interabundance of angles, volumes, and all the physical characteristics of time-space velocity, force, wavelength and frequency, directional orientation, and systems consideration. And Synergetics always identifies Euler's edge line E as representative only of physical energy vectors or metaphysical lines of unique interrelationships. Okay? These vectors are discrete lengths and they're the product of physical velocity of mass operating a given angularly describable direction in respect to a given axis of observation. Okay? So Synergetics uses science. Any triangle is always 180 degrees and any tetrahedron is always 720. Those relate to the half spin and the spinner. How do the angles from Synergetics quantize all space and create structure? From Synergetics, we see that the tetrahedron has 720 degrees of angular variation about its 4 vertices. The octahedron has twice this, or 2 tetrahedrons amount. The prism has the same. If I need to lift my screen more, can you guys see the numbers? It's not that big of a deal, maybe. The cube has 3 total tetrahedral ratios of angular momentum, etc. So when universe encloses all space, it seems to be using angular momentums in a whole rational unit way. Angles must be used in the correct measure ratio and understood as behaviors between various things. These 54 degree, 44, and 35 degree 16-minute neutral angles, along with the 45 degree and 90 degree angles, are all the angles the universe needs to fill all space and allow EMR to structure polyhedral continuums. We will recall from Planck's constant sets the gravitational constant that all universal angular momentum can be measured by Planck's constant. For instance, the 45 and the 90 degrees are there. I don't think I meant to leave that into this lecture, but no worries. I think this looks like notes. You'll notice then that we've got the 5 degrees, the 54 degrees, and the 35 degrees all ratioing to Planck's constant and the fine structure constant. What I mean by I thought this was notes because this is still, these numbers are all correct, but I haven't worked out all the considerations involved. But I have worked out considerations involved in 95012 of Synergetics shows us how all these different angles, look at 54 degrees, 44, 35 degrees, 16, 90 degrees, 45 degrees. Those are the angles that are needed for these 3 different types of all space filling tetrahedron. These are the angles when the tetrahedron is flattened out. This one's neat because all it needs is, oh, I'm sorry, this one is the one. This one only has 54 degree and 35 times 12 degree angles. So only the neutral angles are being used. So there are 3 self-packing irregular tetrahedron that will fill all space without the need of any complementary shape. One of those is the mite, which is the 2A quantum modules and 1B quantum module shown in this picture here. We'll notice that when 2A quantum modules are added to the 1B quantum module, the angles of the irregular tetrahedron called the mite are all now 35, 16, 54, 44, 45, or 90, or a combination of the two neutral angles. Once again, relating those always to a relationship between Planck's constant and the fine structure constant. And that's kind of interesting that those numbers would all work out to be those exact degrees. You know, Bucky says, universe does not throw out these symmetrical number patterns capriciously. So he said something to the effect that, you know, when numbers throwing all these number patterns that are making us pay attention, we should pay attention. In 90566, Fuller shows us the relation between the Earth crust fault lines, steel plate fractionation ratios, and ship bow waves, from EMR to polyhedral continuums to Earth crust fault line angles, to me and you. These neutral angles seem to come into play at all levels of universal structuring. Earth crust fault lines, steel plate fractionation angles, and ship's bow waves are all roughly the same. The 109, which is 2 times the 54, and the 7032, which is 2 times the 35. Now notice that considering 60 degrees is the neutral angle, when you subtract 5/16, you get that. And when you add 5/16 times 2, you get that. Obviously, the 70-degree 32 angle and the 109/2080 relate to the twinkle angle differential from cosmic neutral and to the central angle of the spherical tetrahedron, 109/28. Recall from Dr. Gray's work above that when the Amperian currents are running parallel to each other, they are attracting each other, and when the magnets or half-spin particles are parallel with each other, they are repulsing each other. As shown in the pictures in this place below, the polyhedrons will have a structured domain if the electrostatic repulsive and gravitational attractive angles linked to the neutral push-pull quantized space angle zones of quantum mechanics, dipole magnets, and the forces related to Amperian currents are all interharmonizing themselves in the correct ratios. When something like energy is traveling parallel to the face of the tetrahedron and enters at the midpoint of any of its 6 vectors, like say I was just on this flat plane right here, and I was going exactly straight like this. If I go up straight all the way to the tip of the tetrahedron, that's 70 degrees in 32 minutes. If I go right to the middle and then come out the other side of this yellow one, that's 35 degrees in 16 minutes. If I come walking along here, oof, and I come up this angle here, that's 54 degrees, 44 minutes. It can do this at 12 degrees of freedom because it has 3 different entrances on 4 different face planes. When something is traveling parallel to the face plane, okay, I already did that. Okay, so this is what's cool, you guys. If we draw 8 lines from the center of gravity volume of the tetrahedron towards 4 vertexes, as well as to its 4 central points of its face, the angles are 54 degrees, 44 minutes. When expanding or contracting omnidirectionally, the angles of movement for the 6 vectors in relation to the face planes is 35 degrees, 16 minutes in relation to the center of gravity. The 4 faces and the 4 vertices of the tetrahedron all expand omnidirectionally away from the center of gravity at 54 degrees, 44 minutes. When expanding or contracting, there's energy or mass entering or leaving the system. This shows that the energy entering or leaving the system in an omnidirectionally expanding or contracting tetrahedron does so in relation to the neutral angle zones of attraction and repulsion that we've been speaking of. There's probably a lot of important stuff here, but I know we want to get done by the hour. So let me go ahead and move through here. These are related to Gibbs phase rule, and this may help us to understand a little bit about why the vertex, face, and edge bonding properties of molecular structures are all interrelated to the EMR and gravitational fields. For example, when the vertex to vertex hookup of 2 tetrahedrons hooks up at this degrees, the liquid edge bond hooks up at this degree, and the solid face uses both angles. A rhombic dodecahedron has the same. When you draw a line from here to here and a line from here to here, you got a 90-degree central angle. The vertex angles are then the magic angles we've been speaking of, 54-44 and 35-16. I'm going to move through this. You can read all this if you want to later. Like I said, it's all written on there. So maybe this is important here. So, oh yeah, this is nice here. Hang on, you guys, I'm sorry. So Notice how these ratios are similar to RD. So these angles help us to understand how energy can enter into the center of gravity of a polyhedral system and turn around and leave through one of its vertexes, edges, or faces in accord with the necessary coupling angles or neutral angles. When energies enter or leave polyhedral systems, they do so within the neutral attraction repulsion zones of the Amperian electric current and the neutral attraction repulsion zones of the magnetic force lines. This is how EMR can combine in specific angular ratios to enclose all space. This enables EMR to enclose all space and simultaneously permit other EMR as well as mass particles to stabilize their rotational momentum in relation to other moving bodies at relativistic speeds in order to create zones of contact or critical proximity zones wherein two or more bodies can hook up. Imagine two space vehicles needing to hook up in outer space. They need to vary their angles and reduce their wobble so the port openings between the two space particles will be aligned. Where in nature can half-spin particles encounter magnetic fields and Amperian currents? When they are in critical proximity with other half-spin particles. The electromagnetic charges of other particles creates a spin angular momentum vector reorientation of 54 degrees 44 minutes so as to prepare the particles for coupling. These are what may be considered coupling angles. These angles show us how nature neutralizes the electrostatic repulsive and the electromagnetic attractive aspects of Amperian and magnetic forces, and then intercombines them in order to create the structured IVM polyhedral field. Once EMR is set or stabilizes itself into structure, mass, and charge, it can maintain this harmonically induced balance because the push-pull forces have been equilibrated. It will then use this specific angle to hook up with other half-spin particles. I am going to jump through. This is a fun modelable association I talk about. I might as well do it. And with that in mind, I need to read a bunch of this. All right. So principle of design covariables. The principle of design covariables states that the angle and frequency modulation define all events in universe. There are only two possible covariables operative in all design, their angle and frequency. The principle of function states that a function can always and only coexist with another function, co-functions, and demonstrated experimentally as the outside-inside, convex-concave, clockwise, counterclockwise, tension, compression couples. Function occur only as inherently cooperative and accommodatively varying sub-aspects of synergetically transforming wholes. An example. How does one whole something transform itself in accord with the principle of covariable functions? How can we demonstrate this principle in the real world and relate it to microstructure? How do vectors and tensors transform themselves into one another? Before we have tension or compression in universe, we must first have one whole something to create one whole action as a tensor or a vector. Let us take one whole rubber band. If we pull on it, we're storing tension within the confines of its material domain. This is a tensor vector which is now just waiting to activate its vector tensor propensities or potentialities. With two possible covariables operative in all design in the universe, there are modifications of angle and frequency. As this rubber band is stretched, it stores more and more tension as its wavelength, angle, width gets smaller and thinner, and its frequency length is increased. This is how higher frequency, lower amplitude wavelengths create more energy. This is the first time Earthians have been offered a physically demonstrable model as to why this behavior occurs within the EMR range of universal affairs. This is how a wave can get smaller and hold or store more energy. To prove that the higher frequency, shorter wavelength rubber band stores more energy, just point it at a friend and let loose. The tensor now transforms itself into a vector trajectory. A vector is a mass times a velocity going in a particular direction. Mass times velocity is equal to force. Velocity is equal to distance divided by time. I get silly here, but really what it is that some things in universe are always interacting with other things in order to manifest all human sensed experiences. On this note too then, if you take a rubber band and tense it as much as you can and then pluck it, it makes a certain sound because it's at a certain frequency of vibration because of its tensedness. It's tuning. If you loosen it up a little bit, it's a different tuning and it'll make a different sound and noise because it's vibrating differently within the spectrum of the gaseous field we're in. Read my papers if you're interested in eloquent dispositions of that. So what's happening then is that it's tension within the curvature of the EMR field which holds the potential energy. The tension's waiting to interact with other EMR matter to realize its potential. The bending creates tension and potential the same way bending a rubber tube does. If we bend or curve a rubber tube, the inside of the tube's arc will become compressed and the outside of the tube's arc will become tensed. This is the same thing which happens with EMR. The cyclic spin domain coils of the EMR will become compressed on the inside of the arc and tensed on the other side of the arc. That's why super small coils of EMR being wrapped in such cycles increase the amount of compression and tension stored. Imagine if we bent a spring. It can only go as far as until its coils are touching of the inner arc, but the EMR has omnielastic compression and tension. And so the amount of energy which it can store is potentially F-1 or infinity -1, depending on how small that angle is or the amplitude and how high the frequency gets. So the IVM regulates molecular structure. We'll notice then that the tetrahedral represents not just the model, but the actual geometrical structure, which universe uses to structure EMR into mass and matter. See, from the structured flow of EMR with those currents we're talking about into real atomic structure, molecular structure, the tetrahedron sets the number scale and geometrical pattern based on the internally transforming six-dimensional IVM, or six-axis metric, and its four-dimensional external field, which never changes, at least insofar as its ratios. 2f squared plus 2 is the outer number of spheres on the tetrahedron's layer. Put 1, 2, 3, 4, and that's all the total number of external spheres. Take away the 2 for the polar spin, and you get the total number of electrons on the subshells. 2f plus 1 is the total number of orbitals in each subshell. These are all basic formulas. You'll see the number of subshells and the number of electrons in each subshell, and then the electrons fill the subshells in this way. These add together to fill the 7 electron shells. So that if you'll notice in the right-hand side of Mendelev's table, you got helium, neon, argon, etc. with 10, 2, 10, 18, 36, etc. This is how they build up from the subshells. Now the IVM sets the scale for molecular structure. Arthur Young, a long time ago, he told me that there was these relationships related to the number of closest packed unit radius spheres in the cube octahedron and the atomic mass unit for 4 different elements. That's explained in Synergetics 419. Arthur told me we need to examine the higher frequencies. I haven't had a chance to do yet. I'll get to that in a second. So basically, there's a lot of other people who have been thinking about this. This guy wrote Proof of Synergetics in the Atom, where he used the closest packed unit radius spheres in polyhedral shapes to fill out more of the atomic structures. Here's an image of a molecule with closest packed spheres as a guide from Wikipedia. The tetrahedron shape is seen in nature, covalent bond molecule. When it's methane, the center is hydrogen, and when it's ammonia, it's carbon, and when it's ammonia, it's nitrogen. This is just showing the relationship of molecular structure, those same number patterns I was showing. You'll see down here it shows 109.47. If we put another tetrahedron in here and connected these other 4 vertexes, we would then have the 54.73 or 54 degrees 44 minutes ratioing. There's a chapter in a book of inorganic chemistry. Let me know that they discovered all these polyhedral formulas that I thought I discovered way before me. This is the name of it. There's where you can see it. It deals with electron counting of closest packed spheres in these metal clusters. They can be counted by these mathematical derived ratios from what are called magic numbers, and those are the various symmetrical closest packed polyhedrons and polygons total number of spheres. And this simple general formulas here are obtained, and they are able to count the number of atoms and electrons. And then he says it's known that as the cluster size increases, there's a transition. It's from one extreme of chemical behavior to another. When there's only tens of atoms, the stuff starts acting like wave behaviors with light scattering properties, superconductivity, and other types of interesting wave-like properties. But when it gets into the 30 angstrom with thousands or more atoms, it starts acting just like our material world. Talks about the wave-particle duality and how we're sending carbon-60 molecules and even bigger molecules of phthalocyanine, 114 atoms, through the double split experiment, and they're turning into waves and then back into particles. Because my time is crunched, I'm just trying to show that then, are photons particles? Is anything a particle? This guy here, Carver-Mead, says in collective electrodynamics that the behavior in electrons and photons is purely in accord with electron wave functions. And he attributes the apparent particle-like behaviors to the quantization effects and the eigenstates. He says that this evidence of exclusively wave nature of both light and matter, he gives 10 examples of pure wave phenomena. You'll have to look at his book if that interests you. Einstein was pretty curious about all this. He says this double nature of radiation and of material corpuscles has been interpreted by quantum mechanics in an ingenious way. And amazingly, it just appears to me it's only a temporary way out. Are photons particles? See this article here by Jeffrey Harries. He gives scientifically reproducible experimentation, which shows that they may not be. When he uses a 500 nanometer photon laser to calculate the total number of photons, the specific volume, he comes up with the fact that the photons considered as points are 78,000 nanometers apart. See, but they're only supposed to be this big. Photons are described by McGraw-Hill Technical Dictionary as a single mode of polarization of the magnetic field, and so it must have a dimension of lambda in all directions. Since the wavelength is 500 nanometers, the photons are 156 wavelengths apart. That's impossible. Therefore, the concept of photon as a particle may be wrong. I explained in some of my work that when it's traveling, it travels as a wave, and when it interconnects with matter, it acts like a particle. He talks about a homogenized egg in Synergetics. Here's some number transformation phasing. This is probably now getting into my work. You'll notice at the top here, there's some numbers. This paper in its extension is on the website if it interests you. You'll notice that when we get to 135, 136, 137, 138 numbers up there, we get some really interesting number patterns going. The 135 frequency has 1836 times 5, total number of spheres added, that frequency. It has 1836 times 30, total number of vectors added, that frequency. The one with the 136 spheres has 9,360 spheres to its edge length. So tetrahedron that has 136 spheres to its edge length has just added 9,316 spheres, and this is equal to 2 times 34 times 137. If you multiply that number by 1/137th, you get 68, and if you add that back into the system, you get 9384, the MeV of the proton. Total number of vectors is that number times 6. Total number of vectors added is that number. Total numbers in that polyhedron, 1836 times 137 times 10.
No, we only have a few minutes. Can you sum up?
Yeah, let me just brief up. So, okay, so I appreciate you guys' time. All these vector patterns then in those different transition phasings are showing Planck's constant, the fine structure constant, the MeV of the proton, all kinds of cool stuff. Like I say, this is available so people can read it. And then I talk a little bit later here in this next chapter here, just how they all transformation phase and how they're discovering in string theory, this whole special unitary group has a symmetry of dimensions with n squared minus 1. And I show how n squared minus 1 relates to the total number of tetrahedrons vectors. When a tetrahedron has n number of spheres on its edge length, it has n squared minus 1 times n total number of vectors. And these vectors, once again, represent forces. And so then I explain just basically the number patterns that are coming out of those with 1836 times 5.111, or the ratios between its electron masses and the mass of the proton. And I explain all these different number patterns. Maybe next week, if we're interested, I can go over a little bit more of this. I really appreciate everybody giving me the time to talk about all this stuff. And really, that's the long and short of it. What happens then is a certain total of numbers of these vectors seem to represent all kinds of different forces and masses, which are operatively transforming inside of this big, huge tetrahedron. And that's kind of the long and short of it.
Okay. All right. Well, thank you, Noel. That